So I'll just dive in. The goal for our TOD was the goal of the Wasson Way Trail is to create a transit-oriented development around Lexington Avenue by implementing retail parking lots and safe crossing over Montgomery Road and access points to the trail and housing development. Next slide. So just to give you some location, we're on the far west side of the Wasson Way Trail, right next to Xavier University. This zoomed in a little bit closer. You have Xavier to the west, Montgomery Road, and then Dana Avenue along this way. And we're right on the corner of Dana and Montgomery. So this is the proposed new development. I'm just going to run through this quickly. To the north side, we have townhomes and green space on the side with small amphitheaters and walking trails within. Down on this west end, we have 3 mixed-use buildings with first floor retail and 3 stories of apartments above. And on the east side of the development here, we have retail and restaurant buildings. And then to the far south, we have 3 different row houses that are all 3 stories. And this is just a perspective view to give some more clarity to what the design might look like. We have the 4-story buildings here. Oh, I forgot to mention, we have 2 parking garages, which is what the engineers will focus on, each 4 stories, and then as well as surface parking within the retail site. And as I mentioned, this just gives some better clarity to what the proposed development might look like.
So yeah, as he was saying, our existing overview here, we're going to propose a lot of retail stores throughout the bottom or the southern part of this area, and which will lead to a lot of parking lots as well. So our deliverables for this would be we need established retail parking. We want to provide efficient access points to the bike trails, and then implement a safe crossing at Montgomery Road. So the first thing is, obviously there's going to be a lot of new retail stores which will attract more people, so the need for parking develops here. And so our retail parking lot deliverables, we're going to create the area for the design lot, cost estimate, where the type, whether it's surface or structure, material, and the security and safety. So we discussed with our planner, we have about 111,000 square feet of total retail area, as well as 139 total residential housing units. And according to Cincinnati zoning codes, you need 1 parking spot per 250 square feet of retail area and 1 parking spot per residential housing unit. So after doing the math, we developed that we could have about 350 total spots according to Cincinnati zoning codes. And after discussing with our planner, we decided to put 1 surface parking lot in of 140 spots and then 2 parking garages to meet all the requirements. As you can see here, 1 parking garage there, then in the middle of the retail we have a big surface parking lot, and then to the right is our main 4-story, 105 feet parking garage. And first thing we're going to talk about is the surface parking lot. Total area available for this surface lot was about 47,000 square feet. And I was looking, there's a Kentucky paving guide, and as you can see this picture right here, this was their diagram for it, for their basic constraints that you need for it. For ours, we have 6-inch aggregate base layer, 4-inch asphalt base layer, and then a 2-inch surface layer. So we have 3 layers. There are 16 feet by 9 feet spots, all angled at 45 degrees, and this is right in the middle of the retail area. And estimated cost is about $233,000, and we got this from using RS means. This includes all the layers, the hauling costs, the grading costs, and we have an Excel sheet on that, but I put that in our actual report. I did not have that up here.
In terms of the safety and security of the parking lot, we decided to have illumination lighting in the parking lot. One point must be illuminated by 2-foot candles. We also wanted to have natural surveillance, keep the parking lot really open and wide, not allow shrubbery or plants to block any views. And also, like you see, we wanted to have panic buttons and emergency phones in case there would be a safety occurrence. Next slide, please. So for our parking garage, we were told to get a ballpark estimate of this. We did this pretty roughly. We went talking with our planner, we wanted a 105 by 105 foot garage with 4 stories. We chose precast because we listened to our report many pros for this, but it does very well in the winter, creating the construction for it, and it was very cost efficient. And with the parking garage, we had 180 spots, and doing RS means calculations along with other sources, we averaged out a final cost to be $1.4 million. With our second garage, much smaller garage, 50 by 50 garage, the square area floor plan, Also 4 stories, precast. This includes 50 spots, and then doing our average calculations with RS means, other sources of case study on campus green garage, we came out with a total cost of $400,000. In terms of the safety for the parking garages, again, we have lighting, production lighting for sustainability, that they last long. We want a security fencing around the ground level, protection of the ground level. We will have vehicle directional signs, parking signs, and exit signs in the garage. And also for return on the garage, we want a ticket distribution pay system where people can pay, like the garages here, tickets.
So our second deliverable is access points to Light Road. Obviously, well, the problem with this is there's no current plans to access the trail from the surrounding neighborhoods. Implementing a safe pedestrian crossway would obviously be greatly beneficial to it. It's crucial to the overall area growth. It allows visitors to use the fast retail and surrounding area. Simultaneously, this includes the residents. It also draws in more community members, providing a safe place to cross the light rail track. Obviously, safety is a major concern with all the residents and people who are using the trail, so we need to eliminate hazards and provide warning devices. Our initial research for a crossing, we looked into an at-grade crossing, bridge, and tunnel crossing. After looking at the cost estimate, bridge and tunnels were going to be way too expensive. The only feasible and realistic option would be an at-grade crossing. For our specific design, there's many types of things you can do for it. You can do to a concrete pouring form, you can do metal panels, or you can do a precast. Several companies nationwide do precast crossings. For these, they're very customizable. There's textured surfaces, you can match the pavements, there's different colors, shapes. They're very ADA compliant. There's lots of anti-skid surfaces you can use. The specific precast model we chose was from a company called Old Cast Railroad. Their product line was called Star Trek Products. For this standard crossing, it's Cooper E80 loading, which is pretty much a typical train or light rail loading. The standard crossings they provide are 8 feet wide, by which there's 3 different lengths you can use, which is 5 feet, 7.5 feet, 17.5 feet. As you can see from the picture here, these are very customizable, and they can fit any curvature track, and they're also made to be very sustainable. This is a typical elevation view of the spec section. Basically, each one is just different depending on the type of loading you're going to have. They all have fine aggregate and structural fill. The top one just has dense aggregate, the middle one has asphalt, concrete, and dense aggregate. The bottom just has basic fill. For our standard crossing, which is a standard cross section, which is the top one of just fine aggregate, dense aggregate. Because it's only going to be used for pedestrians going 2 ways from surrounding neighborhoods, 8 feet by 7.5 feet should be fine. Per federal accessibility guidelines, 48 inches is all you need for width, and this is obviously compliant. As I said earlier, this is Cooper E80 loading. You might think maybe precast model might be hard to install. It's actually very easy. In each corner, there's 4 embedded hook anchors. You can pick it up and just drop it in basically. And when you're installing it, it has to have 5% running slope and 2% cross slope per ADA guidelines, and the contractor would have to get with that. For safety signage, the Federal Railroad Administration actually says that human factor accidents are going down, so the safety signage is going up nationwide. Protective measures such as signs and lights are usually used for 15 miles per hour of light rail track. These are usually used ahead of time, 20-30 seconds for pedestrians. And also if you want to invest in surveillance and bridge telephones for safety, it's also helpful. There's different types of treatments. For passive treatments, it's basically just anything that's not mechanically moving. Signs, tactile surfaces, channeling barriers, swing aids, anything that's not moving basically. The other type is active treatments. This is things that are moving, or maybe they're lighting, or you can hear, such as flashing signs, auto devices, automatic gates maybe, or lever arms such as you see on a railroad track crossing the street. This is just a rough sketch of what we use. We're not going to use any active treatments because it's just basically a pedestrian crossing. These 3 lines are supposed to indicate gates or channeling barriers. Basically, the pedestrian crossing this way would have to zigzag through that. And what it does, it faces the pedestrian towards the light rail track, which is here in the middle, and it puts them in a direction where they can see the light rail coming, and it's a lot safer. There's 4 signs, you could have whatever you want, look both ways or stop here. These are just tactile surfaces like truncated domes to alert you more. For our cost estimate, I interviewed someone over the phone. They said it's about $12,000 per linear foot, and if you have 7.5 linear feet. Tactile services, signage, and barriers all included. The total is around $11,000, but this does not include labor and installation.
All right. The third design is focused at the intersection of Watson Way and Montgomery Road. Here's a little background about Montgomery Road. Average annual daily traffic is about 9,000. 4 lanes of traffic. It's roughly about 50 feet wide, and there's existing railroad track, obviously. And basically, the design is going to accompany a pedestrian bike path and basically light rail crossing. First, I'm going to talk about the light rail crossing. I'm going to talk about the design and the cost of it. First, the light rail crossing design. I got these designs from the Manual on Uniform Traffic Control Devices and also from Federal Highway Administration. As you can see right there to your right is the typical railroad crossing gate. It has flashers, sign, and about 24 feet of arm to it. And basically this is our warning system. Also, in this design, we need to incorporate stop line distance, which is basically where vehicles should stop prior to the light rail track. The stop line needs to be about 2 feet thick, 8 feet from the gate, and 15 feet from the center of the track. Another major design we need to look at is the sight distance. In case if all the gates in the warning system fails, vehicles or drivers need to be able to see if there's an incoming light rail coming through or not. And the minimum distance is 175 feet at a speed of 20 miles per hour. So basically, the cost for setting up the gates and the electronic devices, automatic devices, and the pavement markings comes out to about $200,000. It's kind of a ballpark. Got this from 2 sources, one from IDOT and another one from NDOT. The next thing I'm going to talk about is the crossing over Montgomery Road. Since there's like a university area to the left of Montgomery Road, and then we have the Lexington on the right. So I'm going to talk about the raised crosswalk. First, the first option is to just to have your typical crosswalk, which includes pavement marking, yield signs, and crossing sign. And also in that area, we would reduce the speed limit. So the cost for the pavement markings and the 2 crossing signs, one on each side, will cost roughly around $4,000.
All right, next is our second alternative to cross for pedestrians and bicyclists. And this would be an overpass bridge. The requirements listed here is it has to be ADA compliant, so for every rise of 1 foot, there's a run of 12 feet. The minimum height that I found has to be, for the overpass, has to be 14 to 16 feet, so for our design, we use 15. This is so traffic can travel underneath safely. And then with these 2 dimensions, I found that the minimum ramp lengths for a 15-foot high bridge had to be about 180 feet in length on either side of Montgomery. With the total length crossing Montgomery with 4 lanes and sidewalks included, it is roughly 430 feet, with once again assumed 50 feet height. With the, to get a rough estimate, or a ballpark estimate for our overpasses, I used 2 case studies. One is just an actual bridge, and the other I got a quote from a company. For the first case study, this is a cross-sectional plan, or a cross-section view of what the bridge at Highway 29 and Birch Street would look like in a small town in western Wisconsin. As you can see, this is 4 lanes once again, a little bit bigger median in the middle than what we have in Montgomery, which is resulting in that 500-foot length, which is bigger than what I calculated. The total cost came out to about $2.5 million, and that was including everything: labor, bridge, lighting for the bridges, and design and everything like that. The actual construction cost was just $1.9 million, with about $100,000 worth or so in just lighting and safety features. Alternative 2 with the second case study was the Gator Bridge quote. I actually emailed a guy from Gator Bridge and he sent out a quote for, they strictly do aluminum bridges, designs for that, so it'll be a lot cheaper. With his quote, all he included in there was materials and delivery, so it came out to $621,000 for roughly a 450-foot length of bridge. And this did not include any extra lighting or labor costs. For our final design, we, as mentioned before, we're going to use a standard railroad crossing for the light rail. We decided for safety reasons to put fenced gates in between the light rail and the bike and pedestrian trail. For the crosswalk, we're just going to use a raised crosswalk. We determined that the bridge was unfeasible because with a 180-foot length ramp on either side, it can cause problems with University Station already incorporating their construction and our planned designs for the other side with the retail space and everything like that. Also, with that minimum 175-foot sight distance, the bridge would potentially block that in case the gates did fail and oncoming drivers need to see the train. Also, we would include the standard marking and flashings for safety reasons and stuff like that. Also reduce the speed limit like Kyle mentioned before. Over here, this is just a rough sketch of what the design might look like. Obviously, it's not drawn to scale, but we have accompanied the standards of 15 feet total from the center of the light rail to the stop bar, the 8 feet from the center line of the gates to the stop bar. Here in the middle is the fence gates. Those would come down whenever the light rail is crossing, as well as the other gates to stop traffic. Right in the center is the raised crosswalk that would be used, and it's approximately 10 feet from these gates, and then another 8 per standards from this stop bar.